This is Friday, woohoo, October 24th, and today I am going to go over solving systems of equations by graphing. And to do this, go ahead and turn to page 123 in your textbook, and we're going to see how this works. Before we get started, I just wanted to give you a reminder of what graphing a regular inequality all on its own looks like. For instance, if we had something like y is less than or equal to 2, we'd first start by noticing that it was a less than or equal to sign, so therefore the line we graph should be solid. And to graph it, we have to graph the line y equals 4. Y equals 2 is a horizontal line that passes through 2 on the y-axis. So it goes from left to right through 2 on the y-axis. So once that's graphed, you look back at your comparison sign, and it was a less than or equal to sign, and we shade the area below the line y equals 4 because it's all y values less than or equal to 2. And if I keep saying 4, I apologize. So again, the graph of y is less than or equal to 2. You notice that it needs to be a solid line because you have a less than or equal to sign. You graph the horizontal line that passes through 2 on the y-axis, and since it was less than or equal to, we shade the whole region below the line y equals 4. And that's your answer. So, for instance, in this case, when we graph systems of linear inequalities, we're going to have 2 lines on our paper. And the region that we shade will depend on what is being asked of us. So for instance, let's keep our thing y is less than or equal to 2. And suppose we had a second line, x is less than or equal to 2. Well, we know how to graph y is less than or equal to 2. How do we graph x is less than or equal to 2? Well, we graph the line x equals 2, which is a vertical line through 2 on the x-axis. A vertical line through 2 on the x-axis. And since it was also a less than or equal to sign, then we have to shade everything to the left of x equals 2 because it's less than or equal to 2. But we need to only, so that would be if we were graphing only x is less than or equal to 2. However, suppose we want to graph y is less than or equal to 2 and x is less than or equal to 2. Well, if you notice, the 2 lines cross. X is less than or equal to 2 and y is less than or equal to 2. The lines cross, don't they? They cross at the x point, x equals 2 and y equals 2, don't they? So if we want all values y values less than or equal to 2 and all x values less than or equal to 2, we would shade below the x equals 2, below the y is less than or equal to 2, and to the left of x is less than or equal to 2. We only shade one square because that means that all the values that obey both equations, y is less than or equal to 2 and x is less than or equal to 2. So let's kind of see what that looks like in our textbook. Look at example 1 where it says intersecting regions, which is what we've just talked about. It says solve the system of inequalities by graphing. And part A says y is greater than negative 2x plus 4 and y is less than or equal to x minus 2. So let's just look at the tactile graphic so you have an idea of what's going on here before we really go into solving it. What they did is they graphed each line. They graphed y equals negative 2x plus 4 and they graphed y equals x minus 2. We graphed those lines. It's really how you start. You graph both lines, and then you need to figure out what region both lines have in common. So we need all y values that are greater than negative 2x plus 4. So that's the area above the dashed line. But we also need all the values y less than or equal to x minus 2, which are all of the values below the line y equals x minus 2. And if you notice, they both have opposite slopes, as in y equals negative 2x plus 4 has negative slope, and the line y equals x minus 2 has positive slope. So if you see, they have a region 1, a region 2, and a region 3. Which region do you think both would obey both of the inequalities at the same time? It's region 2, because in region 2, the values are above the y equals negative 2x plus 4, i.e. greater than, but they're also below the line y equals x minus 2. So the triangular region in the middle is the correct answer. Okay, let's check out part B. Part B gives the equation y is greater than x plus 1, and the absolute value of y is less than or equal to 3. So I want to pause for a second before we looked at the tactile graphic and talk about what the absolute value of y is less than or equal to 3 looks like. Well, recall from last chapter, absolute values have two cases. We have this case, y, the absolute value of y is less than or equal to 3 is the original. So we have the case where y is less than or equal to 3. That's the first case. You leave it the same. But our second case is where we flip all the signs. So we also have the case y is greater than or equal to negative 3. So to graph the line, the absolute value is less than or equal to 3, we have to graph the lines y is less than or equal to 3 and y is greater than or equal to negative 3. And then on top of all that, we need to graph the first equation they gave us, which was y is greater than x plus 1. So let's just explore the tactile graphic that they gave us. Okay, so see if you can find the lines y equals 3 and y equals negative 3. They're the two horizontal lines on either end, on either top and bottom of the graph. Because again, to graph an inequality, you have to graph the line that you're given first and then shade accordingly. So they graph the line y equals 3 and y equals negative 3 to account for the absolute value of y is less than or equal to 3. Okay, and for that particular y absolute value one, all the values have to be less than 3 and greater than or equal to negative 3. So that means if we were just graphing this equation alone, we would shade the middle part, because the middle part is less than 3 and bigger than negative 3. But remember, we have an additional restriction. That additional restriction is the other equation we were given. Y is greater than x plus 1. So see that diagonal line that comes across both absolute value graphing lines? That's our line y is greater than x plus 1, or y equals x plus 1 is how we graph it, and the shading makes the greater than or less than part. Well, since y needed to be bigger than x plus 1, we shaded above. But remember, we can't go above 3 because of the other restriction of the absolute value. So we shade in this little triangle where the values are between negative 3 and 3 and also greater than x plus 1. Okay. La 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 la. Turn the page. At the top of the next page, it says, it is possible that two regions do not intersect. In such cases, we say that the empty set, and there's the sign for it, and that there are no solution exists. So let's see what that looks like. Separate regions. So let's solve the systems of inequalities by graphing. And the equations are y is greater than 1/2 x plus 1 and y is less than 1/2 x minus 3. So turn to the thermoform page and look at this tactile graphic. Did you notice something when I read you the equations? Y is greater than 1/2 x plus 1. Y is less than 1/2 x minus 3. They had the same slope, didn't they? What does it mean when two lines have the same slope? Yeah, they're parallel. So as you can tell in the graphic, they're totally parallel. They don't intersect. There's this nice empty space between the two of them, isn't there? Because the one graph has a positive 1 y-intercept and the other one has a negative 3 y-intercept. They're the same line, just one is shifted up higher than the other. But then when you look at the two equations, it says y is greater than negative 1/2 plus 1, which means we shade all the area above the line 1/2 x plus 1. But the other one says y is less than 1/2 x minus 3. So that means for the second line, we shade everything below the lower line. Well, do these regions intersect? Nope. And there's nothing in the middle. So that's why there's no solution that exists, because there's nothing that is both greater than the first line and less than the second line all at the same time. Great. All right. So that's all I want you to know about this section. I would like you to turn to the next print page, and all I would like you to do is do problems 4, 5, and 4 and 5. Okay? Just do problems 4 and 5, and I want to see them somehow. If you can get a picture, whatever you can do. And again, I hope you're feeling better, and I will talk with you soon.